Hello and welcome back. We are on the back of the first set of notes. Today we're going to be talking about something called the Pythagorean identities. Now, they're listed up here, and I'm going to give you a quick overview of kind of where these come from before we start using them, because it is kind of interesting. So if you remember from the from last unit, we talked about something called the unit circle. The unit circle was helpful because we could use that circle to find the sine and the cosine of any angle that we drew in it. Remember, the x value represented the cosine of the angle, and the y value represents the sine of the angle. And that because it's a unit circle, the radius is 1. So this first equation right here actually comes directly from using the Pythagorean theorem in that triangle. So a squared plus b squared equals c squared. So I can write cos squared theta plus sine squared theta equals 1. Now, another thing you might be a little confused about is the way that this is written. So when I write cos squared theta, that's actually the same as writing cos of theta squared. It's saying you're basically taking this number and squaring it. By writing it like this, it just makes it a little bit cleaner. And generally, when we square a trig function or cube it or raise it to any power, they put it between the cosine and the angle, or the sine and the angle. So this just means cos of theta squared plus sine of theta squared equals 1. But you never have to write that. It's always written like this. Okay, so there's the first identity right there. Now the second identity actually comes from dividing these all by the same thing. So if I take all of these and divide them all by, let's say, cosine squared of theta. All right. What happens here? Well, we know cosine over cosine. If you divide anything by itself, that leaves you with 1. If you look at this second one, we have sine squared theta over cos squared theta. Thinking back to our quotient identities, sine theta over cos theta was actually equal to tangent. So sine squared theta over cos squared theta is actually tangent squared theta. And then our reciprocal identity for cosine is secant. So 1 over cosine squared theta is actually secant squared theta. That's where this second one comes from up here. The third one is done in an almost identical way, except for you are dividing by sine. Okay, if you want to try this one on your own, you can. I'm just going to quickly write it down here. So if we have cos over sine, the quotient identities, that is cotangent squared theta, plus sine over sine is 1, equals cosecant squared theta. So these are the three trigonometric or Pythagorean identities. Now to how we use them. If you look at question number 4, it might look familiar because these are the questions from last unit that we would draw triangles for. We'd find the quadrant, we'd draw a triangle, find the third side of the triangle, and then find the missing trig functions. What we're going to do today is talk about an alternate way to look at these problems. So if you look at question number 1, we are given the sine of theta is negative 1/3. And we're asked to find the cosine of theta and the tangent of theta. But then we're given this fourth piece of information here. The cotangent of theta is less than 0. So this right here tells you, is a telltale sign that you're going to be trying to figure out, you need to know what quadrant you're in. So cotangent of theta is negative, which means tangent is negative, and we know sine is also negative. Well, where is sine negative? Sine is negative in the third and the fourth quadrants. So of the third and the fourth, where is tangent also negative? Well, tangent is also negative in the fourth quadrant. So we know we're in quadrant 4. Keep that in your mind because that's going to change our signs at the end of the problem. So let's get back to this. So since we're given sine, we're most likely going to be using this first one here. So I'm going to write down cosine squared theta plus sine squared theta equals 1. Sine is negative 1/3, so I have cos squared theta plus negative 1/3 squared equals 1. Negative 1/3 squared is 1/9. So plus 1/9 equals 1. At this point, we subtract the 1/9, and we get 8/9. And then since we're looking for cosine of theta, not cosine squared, we're going to have to take the square root of this. When I take the square root of that, it's the same as saying square root of 8 over square root of 9. Well, the square root of 8 we can simplify. We can break that into 2 radical 2. So that'll go on top. And then the square root of 9 is just 3. Before I box my answer, double check your quadrant. We're in the 4th quadrant where cosine needs to be positive. So since that's a positive answer, we can leave that. Now, the second part of the question says we want to find, so we did cos, we want to find tan now. So since we're trying to find tan, let's look at what we're given again. We know sine, I just blocked it, was negative 1/3. Since sine is negative 1/3, that means cosecant, the reciprocal, is negative 3/1, or negative 3. So we know cosecant, so we're going to be using this one over here. So let's write that down. Cotangent squared theta plus 1 equals cosecant squared theta. And again, I know that's negative 3. Which, negative 3 squared is 9. Subtract 1, cotangent squared theta equals 8. And then take the square root again. So the cotangent of theta is 2 radical 2. Notice I left some space in front of it there. And the reason I did that is, again, we're in the 4th quadrant. Well, is cotangent positive or negative in the 4th quadrant? It's negative. So the cotangent of theta needs to be negative there as well. The last part of this question is we're not looking for cotangent, we're looking for tangent. So again, remember, cotangent is the reciprocal of tangent. So if I want to find tangent, all I have to do is flip that. So it'll be negative 1 over 2 radical 2. And again, simplifying, we have negative square root of 2 over 2 times 2 is 4. There's the answer. There's tangent of theta. So problem number 1 is completed. This is how we use the Pythagorean identity to find missing things. We are going to do one more example. And in the second example, I'm going to block this off so I don't get that confused. We are given the secant. So up here, find the one with secant, which is the second one here. And we're going to write down tangent squared theta plus 1 equals secant squared theta. And we're going to plug in 6 over 5 squared for secant squared theta. Tangent squared theta plus 1 is 36 over 25, which is 6/5 squared. Subtract 1, we get tangent squared theta equals 11 over 25. And then finally, take the square root. Now, what we actually didn't do in the beginning, which is going to be important at this step, is figure out what quadrant we're in. So we have to figure out if that's a positive or a negative number. So let's go back and do that now that I remembered that we had to do that. So secant is cosine. We know cosine is positive. So over on the side here, I'm going to write this. Cosine is positive here and here. We also know that sine is positive. So of these two, the only place where both of those are positive is where everything is positive in this first quadrant. So that's actually kind of nice. Since we're in the first quadrant, all our answers are just going to stay positive. So that makes it a little bit easier for us. Now, so we found tan of x. Now we want to find sine of x. Well, again, use what we're given. Secant of x equals 6 over 5. So what that means is the cosine of the angle is 5 over 6. Again, just by flipping it. So we're going to be using this first one again. So cosine squared theta plus sine squared theta equals 1. Using this, we have 5/6 squared plus sine squared theta equals 1. I'm going to move this over now a little bit. We have 25 over 36 plus sine squared theta equals 1. I ran out of space here, so I'm just going to kind of work down the side here. Hopefully that's okay. And then we subtract 25 over 36. Well, sine squared theta equals 1 minus 25 over 36 is 11 over 36, which if I take the square root is square root of 11 over 6. And we've found sine of x, which is what we want. So that's what we're going to leave off for today. We are actually not going to be doing the cofunction identities or the even-odd identities yet in this unit. The next lesson is actually going to move on to the next set of notes utilizing some of these things. So because of that, we'll come back to those. So expect the next notes will be there. For a homework assignment, I need you guys to do number 1 through 8 in the homework. All right, I'm going to post that on the teams as well. And again, please reach out if you have any questions whatsoever, and I will gladly work with you on this. And talk to you soon. Bye-bye.